Good afternoon, and thank you for joining us. My name is Linda Coyne, and I am the Media Opportunities Manager in the Research Department at SKC. If you have any questions during the presentation, please write them down in the sidebar on the right-hand side of your screen, and we will answer them at the end of the presentation. With me today, I have Lucinette Alvarado, Certified Industrial Hygienist and Technical Services Manager for SKC, Joseph Elder, Media Lab Coordinator, SKC, and Doug Dallas, President of SKC. I would now like to start on the presentation entitled Dermal Exposures in the Workplace, Application Studies and Assessments. The four contaminants that we will be talking about today are methamphetamine, 4,4-methylene bis, 2-chloroaniline, commonly known as MOCA, nickel, orthophthaldehyde, and phenol. Most health professionals concentrate on air and particulate exposures in the workplace, but it has become more evident that skin exposures need to be addressed. Surface contamination can lead to exposure through the skin or by inhalation and ingestion. More than 60% of regulated chemicals have a skin notation, so ACGIH, NIOSH, and other agencies are investigating surface and skin contamination. NIOSH estimates that more than 13 million workers can be exposed to chemicals that are absorbed through the skin. To properly address surface contamination as it relates to skin exposure, there must be ways to detect these contaminants and properly remove them from the surface and skin. This is a graph of dermal exposure cases, and skin exposure in the workplace is a significant problem in the United States. Both the number of cases and the rate of skin disorders exceed the recordable respiratory conditions. This is data taken from the Bureau of Labor Statistics in the U.S. It represents the rate of injuries and illnesses per 10,000 full-time workers. As you can see, the rate of inhalation exposures have been decreasing while the dermal cases have increased. This may be because exposure assessment in the workplace usually starts with air sampling for vapors and particulates. So how do these chemicals get onto the skin? They can get on through splashing or spraying, breakthrough through gloves, and picking it up from the surfaces. Today I'm going to be talking about two colorimetric surface sampling techniques. The first being a lateral flow immunoassay cartridge, and secondly, treated surface pads that when exposed to the analyte will turn a color. Both of these techniques are semi-quantitative. The first chemical that we're going to talk about today is methamphetamine. Methamphetamine is a hazardous drug that is highly addictive and stimulates the central nervous system. Long-term use can cause anxiety, insomnia, psychotic instances, and cognitive issues. Illegal methamphetamine labs often leave toxic residues in the building. This is dangerous for future occupants, first responders, and remediation workers. A quick test is desirable to determine levels of methamphetamine in these situations. The methamphetamine kit contains gauze or swabs, plastic trays, templates, gloves, plastic syringes that are all used for the extraction process, plastic pipettes, reagents, detection cartridges, small bags, and instructions. So the technology of the kit was licensed to SKC by the CDC. It is based on a colorimetric lateral flow immunoassay cartridge, as you can see in the picture on your right. If meth is present, one red line will appear on the cartridge. If it is less than the detection limit listed for the kit, it will indicate 2 lines, one being fairly dark, the other one being a lot lighter. There are 4 kits available: 50, 100, 500, and 1500 nanogram kits. Here is the process for using the meth check kits. Place the template on the test surface where the contamination is present. Remove the step 1 wetting agent from the kit. Spray the gauze pad 2 times with the wetting agent, approximately 4 inches away from the pad. Next, collect the wipe sample by wiping the surface in a W and a Z pattern to be sure you have covered the area within the template. The last step will be to extract the gauze pad with a step 2 extraction reagent and expel it into a plastic tray. Then 3 drops are then placed in the sample well on the right-hand part of the cartridge. Let the cartridge set for 15 minutes and observe the color formation. As I stated previously, if there is only 1 line, then meth is present. If 2 lines are present, 1 dark and 1 fairly light, this means that meth has been detected. There are some interferences for the meth check kits. Those compounds that give 100% cross sensitivity would be MDMA or ecstasy drug. Also D-methamphetamine and street methamphetamine obviously would be positive for the meth check kit. But other compounds such as D-amphetamine, phenylephrine, ephedrine, and heroin and cocaine are 2% or less cross sensitivity, with heroin and cocaine being way less than 0.1%. So basically, outside of ecstasy and a few of the methamphetamine compounds, we don't have too many interferences. Next, I'd like to move on to new SKC surface and skin products. These products utilize a treated surface pad or a treated detection pad to monitor for chemicals on the surface or on the skin. The chemicals utilizing this technique, and we will be discussing today, are mocha, phenol, nickel, and orthophthalaldehyde. These detection devices are semi-quantitative because the intensity of the color can be related to the concentration that may be present. The first chemical we're going to talk about today is mocha. And some of the uses and properties of mocha are that it's a curative used with isocyanate prepolymers, primarily TDI, to make polyurethane products, sometimes known as cast elastomer products. It's also used as a coating in chemical reactions to set glues, plastics, and adhesives. Mocha is typically supplied as pellets, as you can see on the picture on the right, and it has a melting point of 210 to 230 degrees Fahrenheit. Some of the short-term and long-term effects of mocha are listed below. Mocha can cause skin and respiratory irritation and headaches. When mocha is melted, the heated vapors can cause irritation to the eyes. In addition, the same heated mocha, if splashed onto the skin, can cause thermal burns. For long-term effects, both IARC and the EPA have classified mocha as a probable human carcinogen. Some of the potential sources of exposure for mocha relative to the skin is contamination from tools and surfaces, which could have mocha present. Airborne dust. This would be where you would be scooping mocha from drums into melters and just the overall handling of drums. Vapor. Mocha melters can give off some vapors, but overexposure from vapors is highly unlikely and usually very, very low. The ACGIH TWA is 10 parts per million for mocha with a skin notation. Let's now talk about assessment and removal strategies for mocha in the workplace. SKC, as I stated, has a new group of surface and skin products for aromatic amines. Keep in mind that these surface and skin products are not specific to mocha, so any aromatic amine could interfere with the swipe product. We have colorimetric surface and skin swipes, PermeaTech sensors or pads that can work under a glove under work conditions to determine breakthrough parameters under actual conditions of use. We also have decon solutions to remove mocha from the surfaces and skin cleansers to remove mocha from the skin. The surface swipe is approximately 1 inch by 1 inch and contains a plastic tab on the back of the treated swipe material. The tab is used to easily wipe the surface for contamination. This would be true of all surface products that we offer, not just for aromatic amines. Surface swipes help identify work practices that may result in exposure. Although this chemistry is for aromatic amines or mocha, SKC has many other chemistries for different compounds, including isocyanates. Skin swipes for mocha contain 2 sections, an indicator section at the top of the swipe and an untreated cloth portion, which will be used to wipe the skin. The surface swipe cannot be used to wipe the skin as it contains chemicals. So the procedure is to wipe the skin with the cloth portion of the skin swipe pad, and you can see that in the picture to the right. Pour 1/4 inch of cleaning developing solutions for aromatic amines into the small cup provided in the kit. Place the skin swipe pad in the cup, cloth end down, and color detection strip up. The developing solution will wick up to the color detection strip, and a color change will occur if mocha is present. The color will develop in approximately 3 to 5 minutes, and mocha will produce a red-orange type color. But you can see off to the right, as I mentioned, a person wiping their hand with the cloth portion and also the skin swipe itself in the cup with the liquid with some red detection at the top of the swipe. Toxic chemicals can permeate through protective clothing such as gloves, especially under workplace conditions of stretching, pressure, and abrasion. The PermeaTech sensors look like small Band-Aids, but on the outside is a colorimetric pad, much like the swipe products. And you can see in the picture above the pad on top of the PermeaTech. These will turn color upon exposure to an aromatic amine such as mocha. The PermeaTech is placed on the thumb, middle finger, and the palm of the outside of the glove. We recommend double gloving when first evaluating the performance of new protective equipment. Then, after a certain time period, usually 1 to 2 hours, the first glove is removed along with the 3 PermeaTechs. For aromatic amines, the PermeaTechs must be placed on a clean surface and then sprayed with cleaning developing solution. If there is a color change, the glove may not be acceptable for use in the workplace. Decontamination solutions and cleaning developing solutions are used to decontaminate surfaces. Identifying the source of contamination is important, but we must have a way to remove the chemicals from the surface to prevent future contamination. Decon solutions perform this function. The process for this is to wet the surface, the contaminated surface, with aromatic amine cleaning developing solution. Use an abrasive pad if necessary to enhance penetration. Do not rinse the surface with water before applying the decon solution. Next, spray the area with the decon solution for aromatic amines and allow it to react for at least 15 minutes. Then, after that time period, rinse with water and wipe up the area with paper towels or cloths. It is good to recheck the area with a surface swipe to verify decontamination is complete. If color develops on the swipe, repeat the steps until the area is clean. Wear gloves always when decontaminating the area. Skin cleansers are just as important as having a skin swipe to detect the chemicals on the skin. It is important to be able to remove these contaminants from the skin. DTAM Skin Cleanser and DTAM Gold will remove chemicals from the skin and are non-toxic, biodegradable, and gentle on the skin. They are for the chemicals that are partially soluble or insoluble in water. Again, it is very important, much like the surface decon, to have a skin cleanser that will remove the contaminant from the skin. It may come as a surprise to many, but soap and water are not always the best way to remove a contaminant after an exposure. The DTAM skin cleansers were designed to solubilize and remove contaminants from the skin that are not soluble in water. In other words, these compounds are either partially soluble or insoluble in water. All of the components are formulated, as stated earlier, with non-toxic biodegradable solvents that are gentle to the skin and solubilize the contaminants on the skin for removal. It is amazing how many skin cleansers on the market that contain toxic solvents that can damage the skin. So the procedure for this is to apply the DTAM directly to the contaminated skin area. Do not wet the skin prior to applying the DTAM. Rub the DTAM gently to work up a white lather. Rinse the DTAM from the skin with lukewarm water and dry with a paper towel or cloth. Retest with a skin swipe to verify that decontamination is complete. Repeat if necessary. I wanted to talk a little bit about a DTAM efficacy study that was conducted by the University of California. And it was comparing the ability of water, 50% soap and water, corn oil, and a polyglycol-based cleaner to minimize absorption of isocyanate, MDI in particular, into the skin. The data show that corn oil and DTAM, which is the polyglycol-based cleaner, are more effective than water or soap and water in limiting the transfer of MDI into the skin. And this is because MDI is more on it's closer to being insoluble than it is to being soluble in water. And this is related all to the solubility that I've been talking about with the DTAM products. So we have put together a skin decontamination selection guide for DTAM Skin Cleanser and DTAM Gold. I would like to talk about this guide. At the top, the log KOW, or the octanol water coefficient, is related to the polarity or solubility of a chemical. So across the top of this table, you will see the log KOW numbers from less than 0 up to 8.0. There are chemicals listed under each grouping of log KOW. For example, we just finished discussing MDI efficacy studies in a previous slide. And as you can see, MDI is listed in the very insoluble in water category in the last column. DTAM Gold would be appropriate for MDI. Those compounds between 0 and 1.5 could probably use either DTAM skin cleanser or soap and water. But as the log KOW gets to 1.5 or larger, DTAM or DTAM Gold would be more appropriate. Anything with a log KOW greater than 1.5 should use a DTAM product for maximum removal of the chemical. These chemicals, by the way, all have skin notations. Our goal at SKC is to put together a table of the log KOWs and the name of the chemical and provide the user which skin cleanser should be used: soap and water, DTAM skin cleanser, or DTAM Gold. Remember, solubility is the key to effective removal from the skin. Next, we're moving on to phenol. The largest single use of phenol is manufacture of phenolic resins. Exposures to phenol can also occur in the petroleum industry, manufacturing of nylon, herbicides, fertilizers, explosives, and photographic developers. It is also used as a cauterizing agent, a topical anesthetic, and as a chemical skin peeler. It can be found in low concentrations in many over-the-counter products, including preparations for treatment of localized skin disorders, camphorphenic lotion, in topical preparations, Sting Ease, and in throat sprays and lozenges. Some of these I have used myself, Chloroseptic, Ambisol, and so on. Studies show that phenol is absorbed rapidly from the lungs after an inhalation exposure. The effects of phenol, first of all, it has an 8-hour toll of 5 ppm and a skin notation. Phenol is absorbed rapidly from the lungs. It's very irritating to the skin, eyes, nose, throat, and central nervous system. Dilute solutions of phenol can also cause burns. In severe exposures, it can cause liver and kidney damage, convulsion, and tremors. Phenol vapor and liquid can penetrate the skin quickly and even result in death under the right conditions. SKC has some phenol products for surface and skin detection. We have surface swipes, skin swipes, cleaning developing solution, Permeatech sensors for gloves, and DTAM skin cleanser is a good cleanser to remove phenol from the skin. But on the right, you can see in the upper right, we have the skin swipe with the detection pad at the top and the untreated cloth on the bottom. And then we have the swipes to the left a little bit, and you can see the plastic tab that you use to wipe the area. And then on the lower right, this is the color that you will see, a reddish orange color for phenol. So how to use a surface and skin swipe for phenol. For the surface swipe, lightly spray the contaminated area with the phenol cleaning developing solution. Wait for 30 seconds. Take hold of the tab on the back of the surface swipe and wipe the area. Allow 3 to 5 minutes for the color to develop. If present, a red color will develop. For the skin swipe, you wipe the skin with the cloth portion of the swipe. Pour 1/4 inch of cleaning developing solution for phenol into a small plastic cup provided with the kit. Place the skin swipe cloth end down into the cup. The solution with any contamination will wick up to the detection pad and turn a red color. This will happen in, like the swipe, in 3 to 5 minutes. Other compounds that can be detected with the phenol swipe include bisphenol A and chlorophenols. So these would be some interferences, or if they're not present in the area, if phenol is not present in the area with these, then you would be able to use it as a swipe for these compounds. Now we have some sulfuric products that are in development. They're not too far off. They will be completed by the end of this year. We have one for nickel compounds and one for orthophthalaldehyde. Nickel is an abundant natural element. It is found in the soil and emitted from volcanoes. It can combine with other metals such as iron, copper, chromium, and zinc to form alloys. For example, nickel is alloyed with iron to make steel. Likewise, nickel is alloyed with copper to produce coinage, industrial plumbing, and heat exchanger. Nickel is used to make battery plates and electrical components. Most nickel, as you can see from the diagram on the right, is used to make stainless steel. Nickel can also combine with other elements to make nickel sulfide, nickel acetate, nickel oxide, and nickel chloride, to name a few. These compounds are fairly soluble in water, and they are used primarily in electroplating, production of catalysts, and in specialty ceramics. So the main uses are alloys, electroplating, batteries, jewelry, and catalysts. The most common health effect of nickel is allergic reactions. Approximately 10 to 20% of the population is sensitive to nickel. Usually this occurs when jewelry or some other object is in contact with the skin for a long period of time. This usually results in a skin rash of some sort, or in some cases, it's referred to as allergic contact dermatitis. While elicitation of ACD in people through skin contact is well documented, there exists some controversy whether those same effects can be exhibited orally or by inhalation. Less frequently, some people who are sensitive to nickel can have asthmatic attacks when they are exposed to nickel. Workers in refineries or nickel plating plants have experienced chronic bronchitis and reduced lung function. However, during these events, exposures were generally on the high side. The Department of Human Health and Services has stated that nickel compounds are known human carcinogens. Cancer of the lung and nasal sinus have resulted when workers inhaled dust containing high levels of nickel compounds. So the surface products that we will be developing for nickel would be the surface and skin swipes, also the Permeatex for gloves, and also the cleaning developing solution. As you can see on the right, we get a nice, bright pink color with our chemistry that we have. And this product will be available, like I said, at the end of the year in the fourth quarter, roughly. Next on to orthophthalaldehyde, commonly known as OPA. It is a high-level disinfectant for medical instruments, and it's commonly sold under the name Sidex. Sidex is a clear, pale blue liquid with a pH of 7.5, and it is composed of 0.55% orthophthalaldehyde in an aqueous base containing buffers, chelating agents, and corrosion inhibitors. It was used as a replacement for glutaraldehyde because it was much more tolerable, but has now presented more problems than expected. OPA was one of the first compounds to have a surface limit of 50 micrograms in the ACGIH booklet. Health effects of OPA have been found to cause occupational bronchial asthma and contact dermatitis. It has also been found to stain the skin a gray color. There's been some interesting research by the CDC on orthophthalmaldehyde, and so I wanted to talk a little bit about it. They did, first of all, they did a method development study for sampling in air, and then they evaluated 2 different surface methods for OPA on the surface, and I will be discussing one of those. During this study, they noted how reactive and unstable OPA is once collected. And I have listed the reference here for you that can be found in the Journal of Environmental Monitoring. It's a very interesting paper if you want to learn some more about sampling for orthophthalmaldehyde in air or on surfaces. I'm just going to have one slide on sampling in air. I know this talk is on dermal, but I thought this was a good method and I wanted to share it with everybody. And NIOSH will be publishing this method in some time in the future. But basically, it uses the 2,4-dinitrophenylhydrazine chemistry, sampling from flow rates of 0.03 to 1 liter per minute for up to 8 hours. The sample is extracted with ethyl acetate, and analysis is by HPLC UV detection at 369 nanometers. Their findings were really, during some of their studies, is that there's really very little, when you do time-weighted averages, orthophthalmaldehyde in the air. This method will be published in the NIOSH Manual of Analytical Methods, I believe, in the near future. So I'd like to now compare the NIOSH surface wipes to the SKC surface wipes. The surface wipes from NIOSH were prepared from a sheet of polyvinyl alcohol. They cut strips, and after wiping the surface, the wipes were then placed in 3070 acetonitrile water. An aliquot of this solution was then treated with N1-naphthyl ethylene diamine in 0.1 molar sulfuric acid. A visual color determination was made relative to several calibration standards that were prepared. The LOD was stated to be at 48 micrograms per wipe after a 30-minute wait time. The CDC notes that lower LODs could be observed if the industrial hygienist is willing to wait 1 hour or longer. The SKC surface swipe is similar to all the other swipes that I have been talking about during this presentation. First, the surface is sprayed with the cleaning developing solution for OPA. The surface wipe is then used to wipe the contaminated surface. You then let the swipe set for 15 minutes. A brownish color will develop if OPA is present on the surface. The LOD is 45 micrograms, but as with the CDC study, lower limits can be detected if times are extended. The reaction of orthophthalmaldehyde is definitely time sensitive. Both NIOSH and SKC have found the same thing. Glutaraldehyde is not an interference. Other aldehydes are being looked at currently. Again, as mentioned, this product will be available in the 4th quarter of this year. And here is I just wanted to show you, well, first of all, we will be developing surface and skin swipes and Permeatech sensors for OPA. And the picture on the right represents this kind of reddish brown. I call it an ugly color, but it is what it is. And it represents approximately 85 micrograms of OPA on the swipe. So we have pretty good sensitivity there. And I think that we would be able to see easily below the skin limit that's listed in the ACGIH booklet. I have completed the 5 compounds that I've been talking about today, but I'd like to also mention that we have surface and skin swipes and dermal products for not only aromatic amines, but aliphatic amines, aromatic and aliphatic isocyanates, acids and bases, and of course, phenols. And here's a listing of the chemicals that can be detected under each group. And there's a massive list of these. So if they're not all present together, they could be analyzed individually. Many of these compounds have a skin notation, such as MDI, TDI, diethanolamine, and ethylmorpholine, and triethylamine, and orthotoluidine. If you would have a compound that you would like us to test in these groups, please contact SKC and we will work with you on this. In summary, it has become apparent over the last several years that methods are needed for compounds that have a skin notation. Semi-quantitative methods are valuable in locating surface and skin contamination easily and quickly. As the ACGIH develops more surface limits, quantitative methods will complement the swipe line. SKC has added a new line of products since 2019 and is committed to work with our customers on developing methods for new compounds every year. Thank you for your attention.
And Linda, thank you very much. This is Doug Dowis, the president of SKC, and I'd like to thank everybody for attending the webinar today on the dermal surface samplers. I do have some questions and comments here. One comment, someone wrote in that please note that phenol is the active ingredient in sporocidin. I'm not sure if I'm pronouncing that correctly. It says sporocidin, which is illegally used by duct cleaning companies to, quote, sanitize air ducts. So I thought that was interesting.
That is interesting. Thank you.
Yeah, another question that came in is, Linda, can you clarify on your slide, you mentioned that the TWA for Mocha, that the slide said 10 ppb, but you said 10 ppm?
No, it's low. Pretty
It's
sure.
It is ppb, I think. It's 0.01 ppm.
Mocha would never be in the air at 10 ppm, so it's very. I'll double check it here right now, but
it is
10 ppb, but you had said 10 ppm. So
yeah, it is. I'm sorry, it's Lucinette. It is 0.01 ppm or 0.11 milligrams per cubic meter.
Or 10 ppb. Yeah.
Yes.
Okay, yeah, no, that wasn't a misprint. That was the right one.
Okay, and I'm looking at the ACGIH TLV now, and that is a 10 ppb, and it's superscripted as an IFV, an inhalable phase vapor sample. So you do need to collect both the vapor phase and the aerosol phase with that. And if you have any questions about air sampling of Mocha, please contact SKC Tech or your local sales representative to talk about IFV gas and vapor sampling. One other question, and Lucinette or Linda, I'm not sure which of you would like it. The question is, do the aromatic amine surface wipes, skin wipes, and permeation indicators respond to aromatic isocyanates in addition to aromatic amines?
Linda, you want to take that one?
Yeah, there's one aromatic isocyanate only that does respond to the aromatic amine, and that would be MDI.
Yes.
So, but that's the only one. So if you have Mocha and MDI in the same atmosphere, then you would get, more, you definitely get a positive indication.
Okay.
And that has to do with the chemistry that's on the, or is it the other way around now? Let me think. No, that's it. Yeah, the MDA is converted to the amine in that, and then yeah. Okay.
Okay, very good. Well, if you have any other questions, please send them in to SKC Tech, and we'll get back to you. In the next couple of days, you will be getting a link to the recording of this webinar. And we, again, appreciate all your time in attending this webinar, and we appreciate your business too. Thank you very much.
Thank you.
Have a good day, everybody.
Yep.
Thanks, Linda. Thanks, Lucinette.
Oh, thank you.